Okay, here we go. So last thing we're going to do in this unit, we start off talking about rational functions. So just as you're getting ready for the test, the first section, there were two new basic functions. So on your test, it's going to be just like these sheets that I hand out. I'm going to give you a couple of rational functions that you have to translate and stretch and shrink and all that good stuff. The second section, we went through a more elaborate process for graphing because we had some things that were not based on the basic functions. Then in the third section, we solved rational equations and inequalities. Last time we were together, we graphed radicals and we reviewed rational exponents. And so this last one, this last section, we're going to solve radical equations and inequalities. So one more chance to do fun things with the number line. All right, so we're going to solve this equation right here. This is probably something you've seen before, but I'm not assuming you have because this is not something we talk about here in intermediate algebra. So I've got the square root of 2x minus 5 is equal to 5. So what would, if you had 1,000 guesses to know how to solve this, what would you think to do first? Okay, I'm not going to add the 5. That's a good thought. I will want to do that at some point, but right now that minus 5 is trapped underneath the radical, so I can't add it just yet. Not gonna do the 0 thing just yet. By isolate, maybe you're meaning the right thing. I need to get rid of this radical right here. Okay, that's the stumbling block we're having. Like we don't know what to do with that. Okay, so what we're going to do with that radical is, what's the reverse of square rooting something? We're going to square it. So what we're going to do to both sides of this is we are going to square both sides. So I'm just going to go ahead. I'm going to be lazy right here, and I'm just going to throw in a square on that side and a square on this side. Okay, so now that I've squared it, the square root of 2x minus 5 squared, what do you think I'm going to have on the left side of this? Perfect. Thank you very much for participating. I appreciate that. 2x minus 5 on the right side, 5 squared is going to give me 25. And so these are the radical equations that you want to see. When you have a radical on one side, a number on the other side, it's just a matter of raising it to whatever the appropriate power is. Okay, so yes, I will put 1 or 2 of these on the test. I want you to have a good time doing them and be confident and successful. Now I'm going to get the x by itself. Now that I have no more radical, I can add the 5 to both sides, and I have 2x is equal to 30. And then divide both sides by 2, and I get x is 15. Very similar to our rational equations. Sometimes we have problems related to the domain, so I need to make sure that this answer is in my domain. So just a quick check is going to help us determine that. So when I put 15 back up here, in fact, I'll be a good professor today. I'm going to put 15 in. So 2 times 15 is 30. 30 minus 5 is square root of 25, and the square root of 25 is indeed equal to 5. Everything checks out right there. So this is a beautiful answer. And so I'm going to put it in some squigglies right here, and I'm done with the problem. All right, so first one for you, right next door, exercise 1. It's almost the identical problem that you're going to go ahead and solve and figure out what the value of x is. If you got any questions, if you need anything, wave your hand in the air. I will run to you and help you in any way that I can. I've got a square root there. I'm just going to do the same thing from the previous problem. So check your work with mine. If you got something different, let's talk about it. So I'm going to square both sides of this. So what does that leave me on the left when I square it? Perfect. Thank you. I appreciate all the voices. On the right, 3 squared is 9. It's a one-step little problem right here. I'm going to subtract the 4, and I get that x is equal to 5. Okay, it is important to check, make sure that your answer is in the domain. So I'm going to put the 5 in there. So when I do that, this is my check step. I've got 5 plus 4. The square root of 5 plus 4 is equal to 3. Want to make sure that works. 5 plus 4 is 9. Oh, that is a true statement. That's fantastic. This is a beautiful answer. I love it. I'm going to keep it. And there it is, the set with 5 in it. Questions, comments, concerns so far? Okay, yeah, like I said, those are the ones that you want to see. They're pretty straightforward. So the next problem I have is kind of the where things get a little more murky, not too much, but a little bit. So notice in this one, I've got 2 things going on here. Oops, you can't see because I haven't moved the paper yet. So I've got the square root of 11 minus x, but then I've got this minus x right here that I've got to deal with equals 1. So first thing I have to do is I got to make sure you cannot, or it's not easy to do. It's best not to square both sides of the problem when the square root's not by itself. So step 1, make a little note to yourself. You always want to get the square root by itself if you can. Okay, so in this case, that means that I'm going to add the x to both sides to get that square root by itself. So let's do that. That's a fun step. So I'll even write it out. I'm going to add the x to both sides. And what I have is the square root of 11 minus x is equal to x plus 1 or 1 plus x. The order is unimportant on that side of the equation. So far, so good? Anybody concerned yet? Not yet, but maybe you will be at some point. So now we're going to do what we just did on the last problem. I've got to unlock this square root. The way I'm going to unlock that square root is by squaring both sides. Now, here's the big deal. This is the part that I don't want you to miss. On the right side right here, this x plus 1, I'm squaring that whole thing. You don't just square the individual parts. That's the most common mistake students make on these problems. So I'm going to throw some parentheses around it, and I'm squaring that whole thing. Okay, that's important to note. Once you get past that hurdle, though, the rest of this is just introductory algebra. The square root of 11 minus x squared is 11 minus x. I've already asked you that question a couple times. I'm not going to bore you any more than I have to. On the other side, I've got x plus 1 squared. If you need to, okay, because I know you might not be quite up to date on your foiling. If you need to, you come over here. I'm going to do my scratch work, x plus 1 times x plus 1. I'm going to do my first outers, inners, lasts, so that I multiply these 2 things together. That's what x plus 1 squared is. It's x plus 1 times x plus 1. So my firsts give me x squared. My outers give me 1x. My inners give me another 1x. My lasts give me plus 1. Okay, so that's just my scratch work right there. Everybody following along? If I worked too fast, anything bothering you? Okay, I'm trusting it. You're telling me the truth, because why wouldn't you? So then x plus x is 2x plus 1. So you can see that on the right side of this, when I square that binomial, it turns into a trinomial. So now I've got an extra term. At this point, I've got a quadratic. Remind me, because now I'm turning my attention, and we got a final exam coming up about like 5 weeks, I think, after spring break. So I want you to remind me, when I need to solve a quadratic equation, what do I have to do to this whole thing if I'm going to solve it? Sure, I need to set it equal to 0. Whether you're going to factor it if it's factorable, or whether you're going to use the quadratic formula, you have to set it equal to 0. There's no choice in this matter. Okay, so I'm going to do that. I'm going to add the x to both sides. I'm going to subtract the 11 from both sides. And I've got 0 is equal to x squared. 2x plus x is 3 of them. And then 1 minus 11 is negative 10. This one is going to factor, so that's good news. But if you don't like factoring, then you don't have to. You can use the quadratic formula with a is 1 and b is 3 and c is negative 10. And we'll meet at the finish line. We'll both get the same pair of answers for this. So I'm going to do this by factoring. The 2 factors of negative 10 that are going to add up to plus 3 are plus 5, minus 2. You're going to get your chance to factor in just a minute. I'm enjoying my chance. The principle of zero products, which is just the fancy word for when you have two things that multiply to give you zero, you know that either the first one is zero or the second one is zero. One of those has to be true. And then that means I have two possible solutions as long as they are in my domain, either -5 or +2. Don't throw those in a set just yet, because again, just like with rational equations, you can sometimes get fake answers. So we need to make sure that these are in the domain. So I'm going to take the -5. I'm going to go back up to the top with it. Let me just use a different color because I'm kind of making a big mess here. So when I put the -5 up here, I get the square root of 11 minus -5, or 11 plus 5 minus -5 is equal to 1. Can't see? Oh no! I can't see either. I'm not wearing my glasses, so you just all look like blobs right now. So that's, if you want to fall asleep, that's fine. I couldn't even tell. All right, so can you see now? It looks like it. 11 minus the -5 minus -5 is equal to 1. And so underneath the radical, that's the square root of 16. Minus a -5 is +5 equals 1. And the square root of 16 is 4. Is 4 plus 5 equal to 1? Nope, that one, so that one fails. Goodbye, -5. You are not an answer. Let's make sure 2 works or does not work. They could either both work, they could either both not work. One of them could work. It just depends on the problem. You have to check. Okay, so now I'm going to go back with the 2. I'm going to do the same thing. So I've got under the radical, I've got the square root of 11 minus 2. And then outside, -2 equals 1. 11 minus 2 is 9, so that's the square root of 9 minus 2 equals 1. So that's 3 minus 2 is 1. That one checks out. Okay, so that's good. At least all of my work seems sort of worth it because one of the answers did check out and work. So my solution set is the set with 2 in it. So that's a little more complicated than the previous problems because we've got that other variable to work with. So I'm going to slide this down so you can see the whole thing. Your problem is right next door, exercise 2. So go ahead and go through the same steps. If you need anything, wave your hand. I will come and visit you, and we'll see if we can't sort through what the problem is. I'm going to get started with the work on this one. So if you're working, keep working. We'll compare notes, ask whatever question you have. This is probably the most, if any of you go to pre-calculus after this, which is always my context when I'm teaching this class, this is like the most common type of root problem that you will see when you get to pre-calculus and you work with trigonometric things, stuff like that. So I've got several examples to make sure we work through any issues that we have. So first thing I'm going to do is I'm going to add 8 to both sides. So we've got the square root. Let's make sure the pen writes. The square root of 4 minus 3x is equal to x plus 8. Okay. Hoping that step is not the step that would cause anybody consternation. So the next thing I'm going to do is I'm going to square both sides. So again, this is the first opportunity. Sometimes students stumble. So if you don't see what you did wrong here, let me know. When I square the square root of 4 minus 3x, I just have 4 minus 3x. On the other side, when I square x plus 8, if you need to, I'm going to come over to the scrap work over here. So x plus 8 times x plus 8. My firsts give me x squared. My outers give me 8x. My inners give me 8 more x. My lasts give me 64. Okay, so hopefully we'll all have 3 terms instead of just 2. So we've got x squared, 8x and 8x is 16 of them, then plus 64. Anybody having an issue so far? It's a quadratic again, so just like the previous problem, I'm going to get everything on the same side as the x squared. So I'm going to add the 3x to both sides. So I'll do that. I've got, when I add 3x to 16x, I get 19x. I'm going to subtract the 4 from both sides, so I get plus 60. Again, if you don't feel like fiddling with that, you don't see that at factors, that's totally fine. Use the quadratic formula. It will work every single time. But this does factor. I think I planned all of these to factor. Not a guarantee. I don't remember. It's been a while. So x squared is x and x. And the 2 factors of 60 that are going to add to 19. Who wants to volunteer those for me? Sure, that sounds great. 4 and 15. 4 times 15 is 60. 4 plus 15 is 19. That's why we picked those factors instead of something like 20 times 3 or 10 times 6. But remember, if you did attempt to factor this, all you need to do is figure out one pair of factors that works and then work on rearranging the factors. So 10 times 6 gives you 60. I think we would all figure that one out. And 10 plus 6 is 16, so it's not quite right. So then you can move the 2's and the 3's around between those 2 factors and get other pairs of factors that give you 60. Okay, so I'm just giving you a little insight. If you don't like that, just use your calculator and play around with your calculator until you figure out those factors. Again, I'm not trying to math torture you. I'm just trying to teach you how to work with radicals. So these problems, they all should factor if I'm remembering. So my 2 solutions, or my 2 possible solutions here, if x plus 4 is equal to 0, then the first one is negative 4. If x plus 15 is 0, the second one is negative 15. Again, up to this point, anybody got a question, comment, or concern? Have I done anything to bother or confound you? All right, well then let's just check both of these and make sure that they are in our domain. So the negative 4, when I plug it in, I've got the square root of 4 times negative 3 times negative 4 is plus 12. Minus 8, is that equal to negative 4? Well, let's see. 4 plus 12 is 16. Is that a true statement? Is the square root of 16 minus 8 equal to negative 4? Yes, it is. Square root of 16 is 4. 4 minus 8 equals negative 4. Now I'm going to try the same thing with the negative 15. So I've got 4 and then negative 3 times negative 15. Your calculator will tell you that that's plus 45. Four plus 45 is the square root of 49. So square root of 49 is 7. Is 7 minus 8 equal to negative 15? Does that one work out? No, that happens with our radicals. Sometimes the signs get messed up. So that one I'm going to throw away. And so that means my solution set, I'm just going to write it right here, is the set with negative 4 in it. I'm going to put a couple of these on the test. I promise you, there's going to be 2 of them. So if you have any questions, they are relevant to your future. I want you to get those on the test. The problems I put on the test are going to be no harder than this. Okay, but you've got to be able to do this. So if you've got a question, be sure to ask it. Go ahead to exercise 3, get started. If you need anything from me, then just raise your hand. I will do my best to give you any assistance I can. I'm going to get started on this one. Again, not trying to rush you. Some people are done, some people are not done. It's good either way. So this one, I saved you a little work. One step. I've already put the 5 on the other side. So we've got the x minus 5 is equal to the square root of 5x minus 1. So I'm going to square both sides. You can see that being done right here. And so on the left side, the x minus 5 squared, I've got x minus 5. Just making sure I'm on the screen here, x minus 5 times x minus 5. And so when I do that, my first, my outers, my inners, my lasts, my first is going to give me x squared. My outers are negative 5x. My inners are negative 5x. And my lasts are plus 25. So the left side of this is x squared minus 10x plus 25. On the other side, you square the square root and you get 5x minus 1. Up to here, we good with the algebra? It should be stuff you've seen before, but again, I don't like to assume when I don't have to. So I'm going to subtract the 5x from both sides. And so negative 10x minus 5x is negative 15x. I'm going to add the 1 to both sides. I get 26. Looks like that's going to factor. While I'm writing this down, what are the two factors of 26 that are going to add to negative 15? Yep. Lots of negative 13s and negative 2s. Again, if you don't like factoring, the quadratic formula will produce the same two solutions, guaranteed. So if the x minus 13 equals 0, then that means that the first possible solution is x equals 13. If the x minus 2 equals 0, that means that the next possible solution is 2. If you got to this point, you've done a fantastic job. I'm proud of you. I'm glad you're doing well. If you haven't got to this point, make sure to ask whatever questions you need so that you can get here. I'm going to check both of these answers now, make sure they work out. So the first one's 13. So I'm going to put 13 in up here, and I get 13 minus 5 is equal to the square root of 5 times 13. 5 times 13 looks like that's going to be 65. So 13 minus 5 is equal to the square root of 64. Is that a true statement? Yes. 13 minus 5 is 8. Square root of 64 is 8. That's true. So that one checks out. Great job there. I'm going to do the same thing with the 2. Just going to smush it in right here. So 2 minus 5 on the left side is equal to the square root of 5 times 2 is 10 minus 1. So I have 2 minus 5 is equal to the square root of 9. Is that a true statement? No. Square root of 9 is going to be 3. On the left side, I've got 2 minus 5 is negative 3. So that one, not quite. So that's not going to be the answer. So my solution set is 13. Just got one more. Again, I just want to make sure you're comfortable and proficient at doing these steps. So exercise 4, give it a whirl. Again, if you need me or anything, raise your hand. I'll come to you. All right, so I'm going to get started on this problem. Once again, ask whatever questions you need to ask. So first thing, again, I got to make sure that that radical is isolated. So I'm going to subtract the 4 from both sides. get the square root of x minus 2 on the left is equal to x minus 4 on the right. Okay, pretty sure that step's not going to cause anybody any trouble. You've been doing that since middle school. Next thing I'm going to do is I'm going to square both sides. So squaring the left, and then I'm going to square the right. Okay, this is kind of one of the key points. So when I square the left, the square root of x minus 2 squared, you should be looking at x minus 2. On the right, I don't have a square root, so I actually have to go about the business of multiplying those together. So x minus 4 times x minus 4. My first outers, inners, lasts. My firsts give me x squared. The outers give me negative 4x. The inners give me the same thing. And then my lasts give me plus 16. So we've got x squared minus 8x plus 16. Okay. Same exact steps as previous to this. I'm going to bring the x over. So when I subtract the x from both sides, I've got negative 9x. When I add the 2 to both sides, I've got plus 18. This, again, is going to factor, but if you use the quadratic formula, it's going to be great. What are the two factors of 18 that add up to negative 9? Sounds great to me, negative 3 and negative 6. So if x minus 3 is the factor, then that means that the value potential solution is x equals 3. If x minus 6 is the factor, then the potential solution is 6. Last thing to do is to check both of these. So I'm going to put the 3 in up here. So I've got the square root of 3 minus 2 plus 4. Is that equal to 3? Square root of 3 minus 2 is the square root of 1 plus 4 is 3. Is that a true statement? No, it is not. Square root of 1 is 1 plus 4. That's 5. That's not 3. So that is not an acceptable answer. And then finally, the 6. This one I think works out, but I'm not 100% positive. It's been a while. Square root of 6 minus 2 is the square root of 4 plus 4 is 6. And yes, that is true. Checks out. So my solution set is 6. Okay, that's the last one of those I got for you. Anybody got a question? Anything I need to clear up before I move on to the next thing? All right, before I turn my page, I'm just going to reflect on something. It's relevant to our next problem. Up here in the first exercise, we had the square root of x plus 4 was equal to a number. And we chose to square both sides. Why did we square both sides? That's a square root. Okay, the reason I asked that is because at the top of the next page, my first example, example 3, has the cube root of x squared plus 3x is equal to the cube root of 5. So what do you think we're going to do to both sides this time? We're going to cube them. Great. Yeah, I'm going to cube both sides. We're just doing the opposite of whatever that index is. So I'm going to cube the left, and I'm going to cube the right. When I cube the left, the cube root of x squared plus 3x cubed is just x squared plus 3x, so that's not too big of a deal. On the right, the cube root of 5 cubed is 5. Again, not too big of a deal. It's a quadratic because I felt like we needed another one for some reason. So I'm going to bring the 5 over, and I've got x squared plus 3x minus 5 equals 0. Now, I think my purpose in this was to make the following proclamation. We're going to solve this quadratic. It's not going to factor. 5 is prime, so the factors of 5 are not going to add up to 3. So we're going to get irrational numbers. And remember, our cube root, there's no limit on the domain. So I don't have to be as worried about checking my answers. In fact, I'm not going to worry about checking my answers because we won't want to, because they're going to be goofy. So I'm going to use the quadratic formula with the a value of 1, the b value of 3, and the c value of negative 5. Quadratic formula, this is a great thing to remember for your final exam. So when you use it, try to remember it instead of looking it up if you can. So negative b is going to be negative 3 plus or minus my square root of b squared. 3 squared is 9 minus 4 times a, which is 1, and c, which is negative 5. And all of that is over 2a. There is my good friend, the quadratic formula. oops, 2a, 2 times 1. Let's put the 1 in there instead of just writing a. All right, so we're just about done with this problem. Underneath the radical, -5 times 1 is -5. -5 times -4 is +20. So I have 9 plus 20. And then the very last step, which I'm just going to actually write above it so that I don't incur on the next problem, is just going to be -3 plus or minus 9 plus 20 is the square root of 29. That does not simplify. So we are done with our work on that problem. There is nothing else I need to do except throw some squigglies around it. And the reason I don't need to check is because that's an odd index. One of the things we talked about last time is the domain of something with an even index, and we did an example of the square root versus domain of something with an odd index. With the odd index, -infinity to infinity. You don't even need to check it. With an even index, you do have to check. So do exercise 5. It's a simpler version of what we just did. Take you 3 seconds. All right, so once again, I'm going to cube both sides. So that sounds like a great plan. Cube and cube. So the cube root of x plus 9 cubed is x plus 9. 2 cubed is 8. And when I subtract 9 from both sides, your answer should be -1. You are welcome to check that. It is fine. It works perfectly. So I'm just going to throw that in a solution set, -1. So my purpose in those couple problems is just you can do this property with whatever the index of the radical is in order to get rid of it. So we're almost done with equations. At the end, we each have one more example. If there's time, there probably will be time for at least one of them. And in the meantime, before we get to that, we're just going to revisit inequalities. Any questions? Yes, I'm doing an amazing job, I know. So thank you for validating that. Okay, so here we go. We have done inequalities bunches and bunches of times. And in fact, we did it just 2 sections ago with rationals. So help me out here. What is step 1 when I have to solve an inequality? Solve the equation first. Yes. Well, once again, because I'm lazy, we've already solved the equation for this problem. It is on the front of your page, and just in case you don't see it, I'm going to bring it back right here. We solved this equation, the square root of 2x minus 5 equals 5, and we've got the solution 15. Excellent. We already did that. That's absolutely no different than what we've done before. So I'm just going to write my solution set here so that I remember it. Does anyone remember what step 2 to solving my inequality is? I need my number line. Exactly. What does the number line represent? Ah, yes. And we saw that that became a little bit more interesting. Whoops, I don't even know what I'm trying to spell there. Let's try this. We saw that became a little more interesting when we talked about rational inequalities. And it's even more interesting now that we have radical inequalities. I need to find the domain of this radical right here, the square root of 2x minus 5. Well, the good news is we did this on Tuesday. How do I find the domain? What do I have to do with this to figure out what the domain is? I'm sorry, what'd you say? Close. It is involved with 0, but not equal to 0. It's what? Because what's under my radical, it can be equal to 0, but it has to be. Yes, perfect. Can't be negative. So my 2x minus 5 has to be greater than or equal to 0. That's finding the domain of a square root. Remember, that's going to be on the test Tuesday. Remember that. So I'll add 5 to both sides, and I get 2x is greater than or equal to 5. And then I divide by 2, and I get x is greater than or equal to 5 over 2. So in the past, when we've done this with absolute value problems, and when we've done this with quadratic inequalities, and even when we started out with our rationals, we drew the number line with arrows on both sides for negative infinity to infinity. But this says the domain is not negative infinity to infinity. It starts at 5 halves and then goes to infinity. So that's what my number line is going to reflect. So here's my number line. I'm going to put a bracket at this side, and I'm going to draw an arrow to infinity. I know that's a little harder. Okay, so if you have a question, that's a good question to ask. This number line represents the domain we just found. And the domain of this radical does not go toward negative infinity. That's why I cut off the left side of the arrow. And we started this at 5 halves. I put a bracket there because it's equal. We can equal 5 halves. We can have a 0 under the radical. Everybody with me? I know this is difficult stuff, so if you got a question, it would make sense. Okay, well, just like all the other inequalities we've done, there's my domain. I'm going to put my point of equality on the number line, so I'm going to put 15. And now I've divided my interval up, or excuse me, I've divided my domain up into 2 intervals. I've got the interval from 5 halves to 15, and I've got the interval from 15 to infinity. And we're going to check them just like we have in other problems. So I'm going to pick a number from 5 halves to 15. Actually, I'm tired of thinking. It's been a long week. What's a number from 5 halves to 15? 1 is 1 from 5 halves to 15. What's 5 halves as a decimal? 2.5. So give me a number from 2.5 to 15. 4. Sounds great. 3, 9, 10, any of those would be good. 1 is not part of the domain. 1 will not be a solution to this inequality. So I'm going to put 4 in, and you've got your calculator, so you're going to help me out. When I put 4 in, 2 times 4 is 8. 8 minus 5 is 3. So what's the square root of 3? Pop that into your calculator. I'm sorry? Yeah, so what's the decimal approximation? So that because what I need to know is that bigger than 5 or is that less than 5? It's 1.7, so it's less than 5. Would everybody agree with that? You see how we made that conclusion? Okay, square root of 3 is 1.7 and some change. All I need to know is how it relates to 5 because that's what this problem is asking, and 1.7 is less than 5. All right, well, let's get a number from the other interval. What's a number that's from 15 to infinity? 16, sure. Yeah, let's not get too close to infinity. Okay, 16. So I'm going to put 16 in there. So I've got the square root of 2 times 16 is 32 minus 5. And 32 minus 5 is 27. Well, what's the square root of 27? Perfect. Thank you. I knew somebody had a calculator here. I appreciate the help. 5.1. That is bigger than 5. Now we're ready to answer the question. The question said, where is the square root of 2x minus 5 bigger than 5? Which interval is it? Okay, it's from the 15 to infinity. I'm going to put a parenthesis at the infinity end because it's infinity. What am I going to put at the 15 end of this? I'm going to put a parenthesis because I'm not interested in the equality. So I'm going to put a parenthesis there. Let's just do a pretend real quick. Let's pretend this. Okay, I didn't ask this question, but we're going to pretend because I want to make sure that you give me the right interval. Let's say the problem was this. The square root of 2x minus 5 is less than 5. Okay, so all I've done is change the inequality. We don't have to really do any other work. Yes? that is the question that we're just about to answer. A beautiful question. I'm glad you're thinking ahead and processing this. That shows that you're learning, and I love it. Okay, so square root of 2x minus 5 is less than 15. So notice, just as the question that was just asked brought up, I have not included an equality here. That's on purpose. So which interval is that now that I'm dealing with? Okay, it's the 5/2 to 15. Let's start with the 15 end of the interval because it's easier to understand, I think. What am I going to put, do you think, at the 15 end of the interval? I'm going to put a parenthesis because there's no equality. Now at the 5/2 end, I know there's no equality here, but the 5/2 has a bracket because it's part of the domain. So that end of your interval in your radical equation, whether there's an equal here or whether there's not an equal here, you're always going to put your bracket. And if you want to test it out, okay, here's why. Okay, here's what. Let me put 5/2 in up here. So 5/2 times 2 minus 5. This is what's under my square root. So 2 times 5/2, those cancel. And I have the square root of 5 minus 5. What is 5 minus 5? Okay, square root of 0, which is 0. Is 0 less than 5? Yeah, I know it's Thursday and you're tired. So 4 of you agree that 0 is less than 5, but I'm pretty sure everybody knows that. So yes, 0 is less than 5. That's why we can put the bracket there. Okay, because that bracket is related to the domain. Okay, so that is a great question. I'm glad that you asked it, and that's why we pretended there for just a moment. So for your problem, exercise 6, you've already solved the equation. It's on the front page, so you're already one step into this. So now solve the inequality for me, please. All right, so step 1, solve the equation. Well, it's already been done, so no extra work required. The equation's solution set is 5. That's from the front page. Very first problem we did. Step 2, is we got to do our number line. We've got to write down what the domain is as a number line. So here we've got x plus 4 needs to be bigger than or equal to 0. So x needs to be bigger than or equal to -4. So that's my number line. So I'm going to come over here. This is the -4 end, and then here's my number line. It goes off to infinity. So now on my number line, I'm going to put my point of equality. That's 5. And now I'm going to test both of those intervals. I have the interval from -4 to 5, and I have the interval from 5 to infinity that we're going to investigate. So between -4 and 5, you can plug in whatever you want. I like 0, so I'm going to plug that in. And so I've got the square root of 0 plus 4, which is just the square root of 4, which is 2. Is 2 less than 3 or is 2 bigger than 3? Well, I think we'd all agree that it's less than. Okay. And then 5, beyond that, it doesn't matter what number that you pick. Just because I don't feel like thinking too much, I'm going to pick the number 12. The reason I'm picking the number 12 is because I know under the radical, 12 plus 4 makes 16. Can do that without my calculator. Square root of 16 is 4, which is bigger than 3. Again, it doesn't matter what number, though, you picked in those two intervals. You should have the same conclusion as me. So if you have a different conclusion here, that is a valid question to talk about. So we should all come to the same conclusion. Yes?
I got the same answer. I was just curious on why so the first one you do, the sign
Right here?
Yeah.
Yep.
And then on the second column, you put the sign at the grade.
Make this a greater than or equal to, because that's how we find the domain of the radical. So last time in class, we did this. If you remember, I had you graph the basic square root function. Okay, so here's my thing, and the basic square root function looks something like this. The domain of the basic square root function is my x's have to be bigger than or equal to 0. Okay, as far as functions are concerned, we're not putting negative numbers underneath our radical. And so then in class, the next thing we did is after we saw this, I said, okay, then what's going to be the domain if this is my function? What is the domain of something like this? I'm just going to keep it nice and relaxed. So x minus 9 under there. And so the procedure for finding the domain of any radical is to say that whatever this is, okay, I'm circling it, whatever's underneath the radical, whatever number it produces has to be bigger than or equal to 0. So the x minus 9 is bigger than or equal to 0. So the sign here is not related at all to the sign of the problem that we're solving. The sign here has to do with we're finding the domain, and I cannot have negative numbers under the radical. So being bigger than or equal to 0, that is the fancy math way of saying that it can't be negative. So when you say that we're reversing the sign, you are making you are equating something that's not equating. So here, this sign and this sign are not related. This sign in the problem and this sign are not related. Okay, this sign here, the greater than or equal to, that's the domain, what we just saw. This is the sign of the problem that I gave you. We're solving something different. So same thing over here. We're solving the square root of x plus 4 is less than or equal to 3. So what's under the radical? This x plus 4. If I'm finding the domain, the x plus 4 has to be bigger than or equal to 0. Okay, that's why those signs are the way they are. So that's true. These conclusions should all be the same. Now I can answer the question, which interval is my square root less than or equal to 3? Well, that's the interval from -4 to 5. Here's my less than sign, so -4 to 5. So you're going to answer a y for me on this. At 5, I'm going to put a bracket. Why is there a bracket at the 5 end? Because there's the equal right there in the problem. Okay. I'm also going to put a bracket at the -4 end, but this is a different reason. Why am I putting a bracket at the -4 end? Because the domain starts there. Yes, it starts at that point. Okay, so being clear on why. If we were in the land of make-believe like we just were, and if my original problem here was square root of x plus 4, when is it less than 3? So I left the equal off now. So no equal, that's the only difference. It's still going to be the interval from -4 to 5, but here's what the answer would be. Now I'm going to put a parenthesis at the 5 because there's no equal, but at the -4 end, I'm still going to put a bracket because that's where the domain starts. Okay, so I'm just trying to, with as many illustrations as I can, show you why one end of that has the bracket and one end doesn't. All right, so if you're following along, I'm hoping. So we've got 20 minutes. That's enough time. These last two problems, these are sort of important problems. Okay. If you go to pre-calculus, you'll see these a little bit, but it's not, you're not going to see them as much as the other radicals. So what I do, one of these will be a bonus on your test. Okay, so it's important to your future because you can get some bonus points. I have a video for both of these online. So if you get tied up in the work that we're about to do, because there's a little bit more work to these, it's a little more intricate than the previous ones, you can go, I've separated those videos so you don't have to watch today's whole class again, although why wouldn't you want more Perkster for your weekend? Okay, so here's what we've got. Here's the issue with this problem. Okay, I'm going to have you work the one on the right at the same time that I'm doing this. Okay, so the issue is I've got two radicals. And I told you before that the way to approach a radical equation is you've got to get one of the radicals by itself so that you can square both sides and that square goes away. So unfortunately, I don't necessarily have that option first time around. Now, I don't want to square it like this because that's gross. Okay, there's two radicals there. It's going to be foiling involving radicals, and it's just way too much. So here's step number one. Get one of the radicals by itself. It doesn't matter which one you get by itself. So I'm just going to take this minus and I'm going to bring it over to the other side. So here's my step one. I've got the square root of 3x plus 4 is going to be equal to 2 plus the square root of 2x minus 4. So do the same thing on the other problem. You're going to do step by step exercise 7 at the same time I'm doing example 5. I didn't specify, and you can really move either of the radicals over, but I'm hoping that since there was the minus sign, and that's what we just did on the other, everybody was drawn to that second radical. So we've got the square root of 2x plus 3 is equal to 1 plus the square root of x plus 1. Everybody with me so far? So what I've accomplished here is I've got one of the radicals by itself. So I'm going to be able to make one of the radicals go away in this next step. So what I'm going to do now is I'm going to square both sides of this. And here is where the work comes to play. This is the worst step of the problem. After this, it's going to be just like the other problems. I've got to square this side, but I've got two terms, so I cannot just square the individual parts. I've got to put a parenthesis around this whole thing, and I've got to square the whole thing. So here's what it looks like. On the left, I've got the square root of 3x plus 4 squared, so I am left with 3x plus 4. On the right, I've got that binomial. I've got a 2 plus the square root that I've got to square. So I'm going to write that out. 2 plus the square root of 2x minus 4 times 2 plus the square root of 2x minus 4. All right, so I'm going to pause. I would like you in exercise 7, get that problem to the same point. Square both sides and then write it like I have for the next step. The next step's the gross step. Okay, so I've squared both sides. You can see it in red. And so on the left, the square root of 2x plus 3 squared is 2x plus 3. On the right, I've got a binomial. Again, don't just square the individual parts. I mentioned earlier that's the most common mistake students make. I get it. We want to do less work, but it's wrong work. So it's not going to get you the right thing. Okay, so there is, everybody, are we in the same place? Everybody doing okay? All right, now here's the part. We got a FOIL on the left. So here, my 3x plus 4 is going to stay my 3x plus 4. But on the right, I've got to FOIL. So again, track with me. If I lose you, let me know. So here we go. My firsts, 2 times 2. My firsts are going to give me 4. My outers, 2 times the square root of 2x minus 4 is going to be 2 times the square root of 2x minus 4. My inners, square root of 2x minus 4 times 2 is going to be 2 times the square root of 2x minus 4. Somebody might be thinking, hey, Perkser, why aren't you multiplying that 2 times the 2x minus 4 and getting 4x minus 8? Because this 2 is not under the radical, and the 2x minus 4 is under the radical. Okay, so you can't just cross over under the radicals unless they both are. And then my last, square root of 2x minus 4 times square root of 2x minus 4. Now here's some good news. Since I have the same thing times itself, what I have is the square root of 2x minus 4 squared. It's the same thing times itself. So if it was x times x, it would be x squared. If it was 3 times 3, it would be 3 squared. So 2x minus 4 times, square root of 2x minus 4 times square root of 2x minus 4 is the square root of 2x minus 4 squared. I'm going to collect my like terms, then I'm going to pause so you can do the same thing on the right side problem. So I've got the 3x plus 4. Then I've got 4. I've got 2 of these plus 2 more of these. That's 4 of them. And then the square root of 2x minus 4 squared is 2x minus 4. We can do a little bit more on that side, but I'm going to pause because this is the gross step. So if we don't get to finish these problems, that's okay. There's the rest of it's on the video. Go ahead and do that multiplying on the problem you're working. All right, in my mind, this is the hardest step of the problem. So again, if you don't see where something's coming from, let me know. So the left side of this 2x plus 3 is going to stay 2x plus 3. Nothing's going on with that. Now I'm going to do my foiling, my first, outers, inners, last. So my firsts are 1 times 1, so that's 1. My outers are 1 times the square root of x plus 1, so that's just the square root of x plus 1. My inners are square root of x plus 1 times 1, so again, that's the square root of x plus 1. And then my lasts are the square root of x plus 1 times the square root of x plus 1. That is the square root of x plus 1 squared. And you can just barely see that, sorry. So let's make that look a little neater, and then we'll go on to the next step. So I've got one of these plus 1 more of these, that's 2. And then the square root of x plus 1 squared is x plus 1. All right, so on my problem, I'm going to do one more like terms, and then I'm going to do another step. So this 3x plus 4 is completely bored because it's just sitting there. On the other side, I've got 4 minus 4. Those cancel. And so I'm left with 4 times the square root of 2x minus 4 plus 2x. Now, those numbers won't always cancel. That's just happenstance on this problem. That's not what's going to happen on yours. Here's what you do at this point. And then the problem will look more familiar. I've gotten rid of one of the radicals successfully. It took 5 steps, but we did it. So now what I'm going to do is I'm going to get this radical by itself. So I'm going to bring this 2x over to the left. I'm going to subtract the 2x from both sides. So when I subtract the 2x from both sides, 3x minus 2x is x plus 4. I'm going to leave that 4 on the front of the radical. It's fine being there. And now what I'm ready to do, and I'm going to pause, is I'm going to square both sides of this. And this will be the second and final time I have to go through this rigmarole. So I'm going to square this, but while I do that, I want you to do the same thing over here, please. I would like you to collect any final like terms and then move all the stuff not related to the radical over to the left. So on the problem that you are working, we've got the 2x plus 3 right there. And then we've got 1 plus 1 is 2 plus the x plus the 2 square root of x plus 1. Or if you have x plus 2, the order of those two terms is unimportant. But here's what is important. I'm going to move all of those terms over to the left, except for the stuff with the square root. So I'm going to subtract the x from both sides. So 2x minus x is x. I'm going to subtract the 2 from both sides. So 3 minus 2 is 1. And then I've got 2 times the square root of x plus 1. And this is going to be the thing that now you're going to square. So maybe you're already involved doing that, or maybe you're patiently waiting for the perkster. Doesn't matter either way, whatever's floating your boat today. So I've already squared on my problem. I'm going to finish up my problem, and then I'm going to give you a little time to, or whatever time's left from class to finish up yours. So over here, I squared x plus 4, and I got x squared plus 8x plus 16. That's just foiling. On the right, 4 times 4 is 16. And then the square root of the 2x plus, or excuse me, the square root of 2x minus 4 is just 2x minus 4. So I have x squared plus 8x plus 16. 16 times 2x is 32x. 16 times negative 4 is negative 64. And here's what we're going to just do for time's sake. I'm going to get this equal to 0. And then the rest of that, solving the quadratic and checking, I'm going to leave for you. You can just skip ahead to the end of the video. I've labeled the videos in Canvas as example 5 video and exercise 7 video. You'll see them right below the video for today's class. So you can just skip to the end and check your work with my work. When I subtract the 32, I've got x squared and then minus 24x. When I add the 64, I get plus 80. I think it should be sort of obvious, maybe not completely obvious, what the two factors of 80 that add up to 24 are. That's for you. So I'm going to give you, we've just got a few minutes left. I'm going to give you just another minute and a half or 2 minutes to get as much of this side done after squaring it and taking it to the finish line as you can. It's just for time's sake. I'm sorry, I'm not meaning to make you feel rushed. That's why I recorded the videos. So I'm just going to get this one to the suitable point. So on the left side of this, x squared plus 1, excuse me, x plus 1 squared is x squared plus 2x plus 1. That's what you should get when you FOIL that. On the right side, 2 squared is 4. And then the square root of x plus 1 squared is x plus 1. So I have x squared plus 2x plus 1 on the left, and then 4x plus 4 on the right. And now I'm going to bring that 4x plus 4 over to the other side. I'm going to subtract 4x. So 2x minus 4x is negative 2x. I'm going to subtract the 4. 1 minus 4 is negative 3. Again, that will factor. So the rest of this should only take you about another minute or two at most to finish. And then you check those answers and see which one works, which one doesn't, if they both work, or what have you.